Hello, I'm Lộc. In this video, I walk you through building a complex drag and drop app with React and dnd-kit. Our ultimate goal is to master dnd-kit by creating a Kanban-style task manager where you can drag and drop tasks between columns. I will focus solely on drag and drop functionality. You will learn to reorder entire task column, and you will learn to sort task item within the same column. And you learn to move tasks cross column to change their status. Thanks to dnd-kit, building an app like this is perfect fit. dnd-kit is a lightweight, performant, accessible, and extensible drag and drop toolkit for React. I find its architecture easy to understand, highly flexible, and very efficient. We will split this tutorial into three parts. The first part is about the core concept, where we learn the basic building blocks of dnd-kit core with a simple app that drags items across one or more containers. You learn about DndContext, useDraggable, useSortable, and understand some kind of events. The next part is about dnd-kit sortable. We'll explore dnd-kit sortable to implement a fully sortable interface like this. And the third part about Kanban Task Manager, where you apply what we've learned to build a Kanban style task manager. We'll customize collision detection algorithms and combine various events to suit our app needs. To get started quickly, I've previewed some minimal components using Next.js, Tailwind CSS, and Sassian UI with all the dnd-kit packages already installed. You can check out GitHub here and clone. So I'm going to clone this. You can check out this link or in the description. And go to dnd-kit tutorial and run npm install. You can check out the starter template branch to get access to the preview components. And finally, run npm run dev to start the server. And go to browser, open new browser, and localhost 3000. So you'll see that dnd-kit basic and dnd-kit sortable and dnd-kit Kanban. Let's learn the basics of dnd-kit by building a simple app together. The idea is super simple. We just want to drag and drop an item across multiple containers. It should work with mouse, touch, and keyboard interactions. Thanks to dnd-kit, setting this up is really straightforward. Let's take a quick look at how dnd-kit is structured. dnd-kit is built on top of the React Context API. All we need to do is wrap our app inside a dnd-context and use the hooks the library provides. If we want an item to be draggable, we use a useDraggable hook. If we want an item to become a droppable area, we use the useDroppable hook. Here's an important note. When calling these hooks, we must pass a unique ID, so dnd-kit can tell different items and containers apart. Each hook returns an object with all the information we need for handling drag and drop. dnd-kit handles many things for it, like triggering drag action with mouse, touch, or keyboard, checking the position of the drag item, and detecting which drop error is active. However, dndkit won't automatically move the item after you finish dragging. We'll need to handle that manually. It gives us events like on drag end, listen for drag and drop results. For example, when I drag an item here, the event tells us the ID of the dragged item, like drag 1, and the ID of the target container, drop 1. Based on that, we can update the UI. For example, we can hide the drag item and show a new item inside the drop area. Alright, that's the overview. Let's start building the app. After starting the project, go to the dndkit basic page. I've already built the UI for you. In the code base, you can find it under src app dndkit basic and page.tsx. This page imports the basic drag drop component from features basic dnd folder. The basic drag drop component uses two smaller components, mycart and mycart container. The components are pretty simple. I just used the cart component from Saxian and added a few basic styles. Alright, let's add DndContext to our app. I will import DndContext from the package dnd-kit core and wrap the mycart and mycart container components with dnd-context. Let's save the file and open the browser. Okay, as you can see, we're getting a runtime error. Create context is not a function. And here's why. If you are using Next.js, you need to understand the concept of server component and client component. Server components are processed on the server, and on the server, things like the window object or browser APIs don't exist. Right now, Next.js thinks this component is a server component, but dnd-context uses React's context create context API, which needs to run on the client side. To fix this, we just need to tell Next.js that basic drag drop is a client component. Let's go back to our component. I will add the uClient directive at the very top of the file. Alright, let's check it again. The error is gone. How can we make mycart draggable? To enable drag and drop for this component, we simply need to use the useDraggable hook from dnd-kit core inside mycart component. Let's open mycart component. I will import useDraggable hook from dnd-kit core right here. Now let's take a look at the useDraggable function signature. It's a function that takes an object as its argument and returns an object containing many useful properties. Let's try calling the hook. The object argument requires an ID property to help dnd-kit distinguish between draggable components. The ID type is unique identifier, which can be a string or number. I've set the ID to, let's say, drag1. Next, I will log the return object to the console to see what it contains. Let's call it draggable probes. Let's go over some of its key properties. First, we have a setNodeRef property. It's a function. For drag and drop to work properly, dnd-kit needs a reference to the HTML element. SetNodeRef should be attached to that element via the ref attribute, usually on the outermost container. Let's see how to do that. I will extract setNodeRef from draggable props and assign it to the ref prop of the card component, which is basically a div. Next, we have the listeners property. As you can see, it includes handlers like onKeyDown and onPointerDown. By default, dnd-kit supports keyboard and pointer events. They are ready-to-use event handlers provided by dnd-kit. So the question is, how do we use them? If I want the entire card area to respond to dragging, I can add the listener to the card component itself. If I only want dragging to happen when clicking on a specific text element, I would add the listeners to that element instead. In this example, I will add the listeners directly to the card. First, I will extract the listener property. You could manually assign each event like onKeyDown and onPointerDown, and then extract handler from listener property. But spreading is much simpler. So I'm going to spread the listener property onto the card component. Now let's go back to the browser. I'll try to click and drag the element. You'll notice a lot of console logs indicating that the component is re-rendering. Let's look closer at the logs. You'll notice some interesting properties. First is active, which is an object with ID drag1, the same ID we passed to useDraggable. Then we have eDragging true. Using the true pieces of information, we can conclude that my card component with ID drag1 is currently being dragged. You also notice the transform property, an object containing x and y values. The x value shows how far the component has been dragged left or right, while the y value shows how far it has been dragged up or down. dnd-kit uses the CNS transform property to move elements efficiently. Let's see how to apply it. First, I will extract the transform property. Then I will create a style object of type react CNS properties or undefined. Since transform might be null, we need to check. If transform doesn't exist, the style will be undefined. Otherwise, we set the transform property like transform translate 3D function, and the first value is transform.x pixel. And The second value is transform.y pixel, and the third value is 0. Then we simply assign this style to the element we want to drag. As you can see, when I click and drag, the element style updates accordingly, smoothly. The dragging behavior is powered entirely by CNS transform changes, handled automatically by dnd-kit. Finally, let's take a look at the attribute property. It contains several accessibility attributes like areas and row. For example, for better keyboard support, when I press Tab on the keyboard, if the element is a link or a button, it will receive focus, and I can press Enter to trigger actions. However, when I tap to my card, since it is just a div, it won't naturally receive focus. To fix that, we can add row is button and the tab index equal to 0. Okay, now we can focus the element. dnd-kit has already provided these in the attributes property. We just need to spread them onto the card component. You might notice a hydration error. This is a very common issue in Next.js. The error says that the area described by attribute is different between server and client. What is happening? Next.js is a server-side rendering framework. It generates static HTML on the server, sends it to the client, and then JavaScript takes over to make it interactive. If we check the network tab, you will see a GET request to the server when I press Enter. Next.js renders my card component and sends back the document. If you search for area described by, you find some randomly generated value like this. After the HTML loads, the dnd-kit script tries to create accessibility attributes like area described by, but the generated value differs from the one on the server. To fix this, one solution is to provide a custom ID for the dnd-context. I will add an ID like my basic DND. Now, if you inspect again, the area described by value matches. And problem solved. Now we need to create an area where we can drop an item. This is my card container component I've already prepared. We are going to use useDraggable hook to turn this component into a droppable area. First, I will import useDraggable hook from dnd-kit core. The function signature is quite similar to useDraggable. It takes an object as a parameter and returns an object as well. Let's give it a try. Just like useDraggable, it requires an object with an ID that can be either a string or a number. We give it the ID myDraggable1. Let's store the result in a variable called Draggable probes and log it to the console. As you can see, the current property of the node object is known. Just like with useDraggable, dnd-kit needs a reference to the draggable element for it to work correctly. That's why it provides the setNodeRef function. Let's go back to my code container component and apply setNodeRef. I will destructure setNodeRef from draggable probes and pass it to the ref of my code. Now the current property is pointing to the actual DOM element inside my code component. You can also see the active and over properties here. They are both null at the moment. When I start dragging an item, this value change. In the first case, I drag the item, but don't hover over the draggable area. The active probe contains information about the item I'm dragging with ID drag1, but over remains null. In the second case, I drag the item over the draggable area. Now active still contains the drag item info, and over contains the ID of the draggable area, my draggable1. We can use this information to trigger things. For example, changing the border color to visually indicate that this item can be dropped here. We can use this information to trigger things. In this case, I only want to change the border color when any item is hovering over the container. Set a convenient probe called isOver that becomes true when an item is hovering over the draggable area. So let's use it. I will extract the isOver property from the return object. Then I will add a conditional class here. Border amber 500, and the value is over. This means the class border amber 500 will be applied only when isOver is true. And okay, our draggable error is all set up. Let's move on to the next part. So how do we actually load this item into the container? Well, DndContext provides several event handlers that we can use in situations like this. In our case, when drag action ends, meaning the user releases the mouse button, if the element is over a valid draggable area, we want to move that item into the container. To do that, we'll listen for the onDragEnd event and handle it accordingly. Let's add the onDragEnd event to our DndContext. We'll lock the event so we can take a look at the information it gives us. Now I will drag the item and release it. The onDrag event is triggered, and we can see the event data in the console. If we expand it, we can see the active item is drag1, but over is null. That means it will not drop over a valid droppable area. Now let's try dropping it onto the droppable container. And this time active is still drag1, but over is my droppable one. Using the over.id, we can conditionally render my card component inside the container. For example, when onDrag finishes, if there's an over ID, we can hide the draggable item and show it inside the container instead. We'll store the over ID in a state variable, and let's call it over ID. And what's the type of over ID? If we look at the type of the onDrag event, we'll see that the over property has an ID with the type unique identifier, which is just a string or number. So we can either define the type as union string number or import unique identifier type directly from dnd-kit core and use that. I would assign an initial value, so over ID will be of type unique identifier or undefined. Then in the onDrag handler, I will set over ID to event.over (ID). Since event.over can be null, we use optional chaining here. If it's null, event.over.id will resolve to undefined. Finally, I will render my card conditionally. Here's the draggable my card. If over ID exists, I will just return null to hide it. And inside my card container, I will conditionally render my card only if over ID is present. And let's test it out. You can open React DevTools and inspect the basic drag drop component. We can see a state here with the value of undefined. It is over ID state. Now when I drag and drop onto my card container, the onDrag event finds event.over_id is my droppable one, and that gets saved to the state. Because over ID now has a value, the original draggable my card is hidden, and a new my card appears inside the container. You might notice two issues here. First, the drop my card is floating outside the actual card content, and that's because we are rendering a copy of my card, and it still has the classes like absolute, top, left. We can fix that easily by just removing those styles. The second issue is my card appears underneath my card container, and that's due to how that index works. And there's a better way to handle this. which I will show you later. But for now, let's do a quick fix. We'll set a higher Z index for the draggable card. And let's give my card a Z index of 20 and set my card container to Z index of 10. Now let's test it again. And there we go. The card is now correctly positioned on top. As you can see in the final version of the app, we can drag and drop across multiple containers. You will learn how to refactor this for reuse later on, but for now, let's implement it quickly. I will start by copying the my card container component. We'll call the new file, my card container shoe.txt. Next, rename the component to my card container shoe. Then update the ID to my dropable shoe so we can distinguish between the two containers. Now let's go back to the basic drag drop component and copy the usage of my card container, but using my card container shoe. And let's check the browser. It seems like nothing has changed visually, and that's because my card container 2 is in the same position as the original one, and they are overlapping. Let's move it to the center for now. I'll give a class of right 1/2. Great, now we can see the new container and its center on the screen. Let's try dragging the item into my card container 2. Now it shows the card in both containers. Why is that? Well, in the code, we are only checking whether overID has a value, and if it does, we render my card. But we are not checking which container is actually dropped into. So even if we drop into either container, both will render my card. And let's update our logic a bit. Inside my card container, we will check if overID is equal to my droppable one before rendering the card. In my card container 2, we will only render the card if overID is equal to my droppable 2. Alright, let's test it again. Now we can successfully move the item between the two containers, and it only appears in one at a time. Now we are still facing Z-index issues when working with multiple drop zones. And when we drop an item, it appears abruptly without any smooth transition. To solve both of these problems, dnd-kit provides a component called drag overlay. Let's take a look at how it works. Inside the DndContext, near the button, I will import drag overlay component from dnd-kit core. And let's give it some temporary content, just a text label that says hello. Now try dragging an item. You'll see a floating hello element that moves with the cursor. This hello element is rendered inside a DOM node with a Z index of 99. And if you're familiar with how stacking context works, unless you explicitly set a higher Z index on other elements at the same level, this overlay will always appear on top. And this means we can safely remove all the z-index overrides we added earlier. Now, when we drop the item, it even plays a default drop animation. You can actually customize this animation, and you can check the docs if you like to change it. But for now, I think the default looks great, so I will leave it as is. There's one important note here. If you render drag overlay conditionally, for example, only when there's an over ID, the drop animation won't work. Let me show you. Animation stop working. So make sure drag overlay is always mounted, even if the content inside it is dynamic. Now instead of just showing hello, let's render the actual my card component inside the overlay. I will copy my card here and paste it into drag overlay. We've removed any unnecessary classes and just keep what we need for the visual. It works. Now the z-index issue is gone and we get a nice drop animation for free. As you can see here, we are using the myCard component, which uses useDraggable hook inside to display for the drag overlay. However, according to the document, we should not use a component that uses useDraggable hook inside for drag overlay because it can lead to unexpected behaviors. The component used for the drag overlay should have the same appearance as the component we are dragging. Distinguish between components that are only for display and components that are both display and draggable. And for reusability, for example, when displaying multiple draggable components or multiple droppable components, we don't want to copy and paste like we did with my card container 2 earlier. So to make the overlay easier and support reuse, we will create a wrapper component that uses the hook and passes the necessary props down to the actual component. Here how we are going to do it. You can see my card component currently uses useDraggable hook inside. I'm going to remove useDraggable hook. Next, we will create a wrapper component and let's call it my draggable card. And this component will use the useDraggable hook. Render my card component and pass the necessary draggable props for dragging and dropping. So now we have two components, one for drag functionality and one for the drag overlay. Let's update the code. First, we'll remove the hook from my card component. I'll comment out the style variable. This style now be received from the parent component. I will add a new prop called style. It will be a type CSS property or optional. You destructure it right here, okay? As you can see, we need to receive ref, attributes, and listeners from outside. So what are the types of the props? Let's start with ref. If you are using React 19 or version before 19, you might need to use React Forward Ref API. But starting with React 19, we can pass ref as a regular prop. Let's add ref as a prop. Since it can be undefined, I will mark it as optional. I will import the ref type from React. Ref is a generic type that refers to an HTML div element because the card component is a div. Let's pull the ref out and use it in place of setNodeRef. Now for the remaining attributes and listeners. We can look at useDraggable hook to see their types. Attributes is of type draggable attributes. Listener is of type synthetic listener map. Let's add those as props. Attribute is optional and type as draggable attribute from dnd-kit call. Listener is optional and type as synthetic listener map imported from dnd-kit call and hooks, utilities, and let's destructure those now. Now all the type errors are gone. You can see that manually defining the prop types can be tedious. We can use some advanced TypeScript utilities to simplify this. I'll create a new type called draggable props. TypeScript provides the type of keyword to get the type of a value. useDraggable is a function, so using type of useDraggable gives us the function's type. As you can see, it's a function that takes an argument and returns an object. What we care about is the return type of this object. To extract the return type, we use the built-in type return type utility. It's a generic type that takes a function type and returns that function's return type. As you can see, this is the return type of useDraggable. It includes many properties. We only need listeners and attribute, so we use another utility type called pick. Pick is a generic type that takes two arguments, the object type and a union of the property names we want. In this case, attributes and listeners. Now we have an object type with only listeners and attributes. Next, we will remove the manual definitions for listeners and attributes and instead extend draggable props here. I want all properties in draggable props to be optional, so I will wrap it in partial, which makes all properties optional. Now attributes and listener are both optional. Now let's create the wrapper component for mycart. I will copy the file mycart.tsx, rename it to mydraggablecart.tsx, open the file, and rename the component to mydraggablecart. Rename the interface to mydraggablecart props. We no longer need to extend draggable props, so let's remove that. Also delete the draggable prop style definition. Remove the destructure props that we don't use. Uncomment the hook and style usage. I will delete everything in the return block and instead return my card component that we've just updated. It receives children. Style equals style. Ref is setNodeRef. Attributes, listeners, and class name. You'll notice that the ID here is hard-coded. This won't work if we have multiple draggable cards. So I will add a prop called ID with the type unique identifier. Now instead of hardcoding, we'll receive the ID from the prop. Now let's go back to the basic drag drop component. Instead of using my card, I will replace it with my draggable card. Let's assign each of the components an ID, drag1, Now let's check again. It still works, that's fine. I want the border color to change to orange when I'm dragging and the cursor to change to grabbing. Because the drag overlay sits on top of the component being dragged, I only need to add the styles to my card. And let's add border orange 700 and cursor grabbing class. Okay, now the border and the cursor change properly. Let's try using the keyboard. I will press Tab to focus the element. Then press Enter to start dragging. Now I will use arrow keys to move the element. You'll notice that the overlay and the actual element are not visually aligned. The fix is I can hide the real element while dragging. Go to my draggable card and get the e-dragging value from the hook. When the element is being dragged, its dragging will be true. I will set its opacity to 0 so we don't see it. In the class name props, we can use the cn utility. When its dragging is true, the class opacity 0 will be applied. Let's check again. That looks much better now. For my card container, we will also create a similar wrapper like we did for my card. I will go quickly through this part. First, I will delete my card container 2 since we don't need it anymore. In my card container component, I will comment out the hook. I will add a ref prop to the component. We're using is over from the hook to show a border. You could pass is over down, but I see that it's just used to add a class, so we can pass it as a class instead. Okay, now let's copy the component myCardContainer.tsx and rename the file to my_card_container.tsx. Rename the component to my_card_container. Rename the props interface to my_card_container_props. We no longer need the wrap prop. We do need an ID prop with type unique identifier, so we don't hard code it the ID. Uncomment the part where we use the hook. Now render my card container here. It will receive children props. Ref equals set node ref. We can add the border here using class name. Class name an object border amber 500 and is over and pass class name. Okay, let's go back to basic drag drop. Replace my card container with my droppable card container and update the ID so that it's valid. Something went wrong. It looks like I forgot to update the ID in my droppable card container. So let's update it again. Okay, check the app again. It's working great. The next issue we are going to address in this basic DND tutorial is the movement behavior of the drag overlay. As you can see, when I drag the element, it spills out outside the boundaries of the browser window. In some applications, this may not be the desired behavior. To fix this, we can make use of modifiers provided by dnd-kit. Here is the documentation page that explains modifiers. One of the common problems modifiers have solved is restricting the motion of the draggable element within a specific container or boundary. dnd-kit provides several built-in modifiers for this purpose. Let's focus on the section called Restrict Motion to a container's bounding rectangle, especially the one named Restrict to Window Edges. According to the docs, this modifier restricts movement to the edges of the window. It's useful when you want to prevent the drag overlay from moving outside the visible bounds of the window. And this is exactly what we need. Let's see how to implement it. First, you need to install dnd-kit modifier package. I've already installed it for this project. Now, in the basic drag drop component within the dnd-context, we will add the modifier props and pass in an array. I will import restrict to window edges from dnd-kit modifiers and include it in that array. And let's save and check it out. Now the drag overlay is restricted within the browser window, exactly what we want. Hello, in this section, we'll build a sortable list using dnd-kit. What is a sortable interface? Basically, it is a UI that allows user to reorder items by dragging and dropping them. As you can see, what we are aiming to build is a vertically sortable list. Admittedly, building this from scratch would be quite challenging. And fortunately, dnd-kit provides a preview package for creating this kind of interface. And we will be working with the Sortable Preset, which is a preset package. To use it, you need to install dnd-kit Sortable. Let's go over the architecture of dnd-kit Sortable. As you can see, it's pretty straightforward. We will wrap the entire sortable list with DndContext from dnd-kit core. Then we will wrap the list itself with sortable context from dnd-kit sortable. And for each sortable item, we use the useSortable hook from dnd-kit sortable. When a drag and drop operation ends, we listen to the onDrag event to reorder the list accordingly. Let's see how it all comes together. I've already built a basic UI for you. On the web, go to dnd-kit sortable page to see the static list. In the code base, open etc app dnd-kit sortable and page.tsx. This file simply imports and renders sortable cast.tsx from etc features and sortable lists. The cast state is an array of objects with an ID and name. Each card item is rendered with the card item component from carditem.tsx. It's a simple component that renders a card from set CNUI, and receive props like style, class name, ref, and the card object. Now let's wrap the app with dnd-context. If you are using Next.js, remember to add the uClient directive at the top to avoid high duration errors. Also, give dnd-context an ID like my sortable list. This helps prevent high duration issues mentioned in the DND basic previously. Next, I will import and use useSortable context from dnd-kit sortable. Sortable context requires an items props to check the order of items during drag and drop. So what type should items be? It can be an array of unique identifier values, which are string or number, or an array of objects, each having an ID field that is a unique identifier type. So it can be an array of numbers, for example, 1, 2, 3, or it can be an array of strings like this, or it can be an array of objects like with ID and name. So if your data doesn't have an ID, you can derive it. For example, instead of ID property here, we got card ID, for example. You can map over the list and return an array of card ID. So after doing this, item.map and item with ID, card ID, we will got an array of number like this 1, 2, 3. Or we can return an object using like ID and the value is item.card ID. So in my case, the cards array already meets the requirement. So I just pass in. Now let's use sortable inside card item to make it sortable. Go to card item and import useSortable from dnd-kit sortable. useSortable is built on top of useDraggable and useDroppable, so its API will feel familiar. It takes an object with an ID as argument, so I can set it to set the ID to card.id. Call it and store the result in sortable probes. You can log it out to see what's inside. It gives us an object including attributes, listeners, and setNodeRef. We use setNodeRef to assign the ref so dnd-kit can detect the element. Spread attributes and listeners to support accessibility and enable sorting. And we save and check the browser. Nothing moves yet. We need to provide a style with the computed transform for animation. Extract transform from the hook result. And let's define a style with the type of CSS properties, and the style value is transform. We could compute it manually using translate 3D function as we did previously, but we can install a package called dnd-kit utilities, which I've already installed for you. And I'm going to import CSS from utilities, transform to string, and pass transform to. So it will do convert the thing into string for it. Now the item moved to indicate sorting is in progress. It feels a bit janky. Add transition from the hook. I will extract transition from the hook and put it into the style transition. Okay, now it works. You want to customize the transition and do not hardcode it like this, like transition, transform, and 200 milliseconds and ease. It won't work. Instead, configure it in the hook. So in the useSortable hook, I'm going to add transition property. It accept an object so we can configure the transition properties, and it take duration. Let's give it 500, and easing is the timing function. So I'm going to put a cubic bezier and the value which is for bouncing. Sorting strategies define how elements rearrange during drag. So we have default strategy called drag sorting strategy. As you can see, when I drag A to C spot, B and C move up and A slides in. This gives a smooth experience. Please note that this does not swap A and C. It inserts A in place of C. To swap instead, use rag swapping strategy. Let me show you. Import and apply it via the strategy prop in Sortable context. Now dragging A into C's position swaps them. So I will revert back to the default by removing the strategy prop. You see the item snapping back to its original position when sorting ends. And that's because the dnd-kit sortable only handles the UI rendering. To actually reorder the element, we need to listen for the event and update state. The cast state is passed into sortable context and used to render the card item list. When the drag and drop ends, the event tells us which item would drag onto which item. Based on that, we can update the card array to reflect the change. I'll listen for on drag event. We can access the event and extract the active and over properties. Active is information about the drag item, and over is information about the target item to drop onto. And let's log and inspect. If I drag card A and drop it onto card C, because active ID is 1, which is the card A, and over ID is 3, and this card C, you see B and C shift up and A is inserted when where C used to be. So what is the algorithm? Consider 4 items here, A, B, C, D. Suppose I drag C and drop it onto A. Because React state updates must be immutable, we copy the original array. When drag ends, on drag end tells us active item is C and over is A. What we need to do is to remove the active item C. So removing C shifts D into C spot. Then insert the active item at the over index. So inserting at A position pushes A and all items below down one slot. This approach uses default rag sorting strategy. And with rag swapping strategy, you will simply swap two items instead, like this. Let's go back to the code and implement the update. First, I will check the condition. If active.id is different than over.id, we want to do something. Why different? Because I only want to happen when drop onto different item. Because over can be null, so I need to check over if there's over first. Next, let's find active index and over index in the cards by using find index method. Let's create new card variable and assign it to the copy of card state. We need to remove active item in the new card array, so I'm going to use spline. We pass it active index and the next argument is 1. It means we want to delete one item from that index. Supply return an array containing deleted items, and in this case I delete one item, so it gives me back one item. Let's destructure it and call it move item. The next step is we want to insert active item at the position of over item. So I'm going to use spline on new card, and the first argument is over index. The 0 argument here means I don't want to delete item, and the third argument here is we pass move item, meaning that we at the over index position I just want to insert move item. And the last thing we need to do is to update state by set cost equals to new cost. And let's check again. State is updated correctly. And this is how we update the state manually. You can check out the dnd-kit sortable package. It also provides a function to do this so that we don't need to do it ourselves. And we can import array move from dnd-kit sortable. So it will take two arguments. The first argument is the array we are going to modify its cards. And the second argument is from, which is in our case is active index. And the third argument is over index. So it will try to do similarly with what we just did. As mentioned in the DND basic chapter, items sometimes go behind or above other items due to Z index. There's no drop animation. You can't drag an item outside the list, it snaps back. So to solve this, you drag overlay from dnd-kit core. To make it easier to use with drag overlay, we are going to create a wrapper component. What we need to do is create a sortable cart item, which uses useSortable and passes props down to cart item. Now we use cart item for drag overlay and sortable cart item for the sortable list. In cart item.tsx, comment out the useSortable logic. We use ref attributes, listeners, and style from component prop. First, style, using style from prop. Second, for ref, we are using ref from props as well. And next, about attributes and listener. We can add attributes and listener to the interface. Or we can extend it. We need to create a new type. Let's call it sortable props. We will do similarly what we did in the D&D basic chapter, but I'm going to do it fast. So we first need to get return type from useSortable. And then from return type, we got an object. So we are going to pick from the object, attribute, and listener. And it will construct an object type. And we want all properties in the type to be optional. So I'm going to grab it inside parcel. Next, we'll need to create sortable cart item. So what we need to do is we copy cart item. And then rename the component to sortable cart item. And we need to also rename the interface to sortable cart item props. New interface only accept cart and class name, so I will clean up unused prop. Will you use sortable again? I will uncomment it. We need to render cart item that we just updated here, and with all the necessary props. And let's go back to sortable cards. We need to replace cart item with sortable cart item. In DndContext, at the bottom, I'm going to add drag overlay component from dnd-kit core. So let's render the cart item here, not sortable cart item, but cart item. And because it's required the cart property, so for now I just give it the first item in the cart state. Okay, let's check it again. So this will fix its ZNX problem and allows dragging outside the list, and it shows the default drop animation. Let's dynamically render the drag item overlay. What we need to do here is we will keep check the active item when we're dragging. We need to listen to on drag start event. The event will give us active ID so we can update the state when on drag start happen. Also, I can create a state. Let's call it active ID. Set active ID and use state. The type here is unique identifier, so the ID can be string or number. Now we can compute the active item by just find from the card where the card ID equal to active ID. Now when we got active card, we just need to pass to the probe card. And because the files method can be undefined, so maybe we need to check the active card condition first. If there's active card, we render the card item overlay. Otherwise, we render nothing. Now we see correct card item overlay. To style the sort item when dragging, you can go back to sortable card item and get is dragging from sortable props. Apply conditionally class. So you might want to reduce the opacity. So I'm going to give it a class name like opacity 50. So basically it 50% when it's dragging is true. I give it a cursor wrap as well. You can make it fully invisible by let's say opacity 0. And finally, let's give a little bit style on card item overlay. I'm going to give it a border amber 500 and the cursor wrapping. And let's check it again. Now we got overlay with the border and the cursor wrapping. Okay, that's this for the sortable section. Thanks for watching this far. Now comes the part that I've been most looking forward to. We're going to build a Kanban style drag and drop task management app. An app like this has many features, but we will focus on one of the most important feature, drag and drop, especially when dealing with nested cross-sortable lists in complex layout. We will apply everything we learned from the basic dnd-kit and dnd-kit sortable to make this happen. So let's get started. To save time, I've previewed the UI for you. After you pull the code and run the app, navigate to dnd-kit Kanban page and you will see the UI. And here is the task management title. We have three default columns: to do, in progress, and done. You can add a column or you can delete an existing one. Each column contains 8 task item inside. As you can see here, to do contain multiple to do items. Let's walk through the components that power this UI. As you can see here, we have task column component, and each task column component is going to render many task items. To find the components in code, you can open the dnd-kit Kanban page, and you will see that it is going to import task management from feature, Kanban board, component, and task management. In the return method, as you can see here, we have a list of columns and we map over it. And for each column, we are going to return or render a task column. And with each task column children, we render a task item. And that matches exactly what you see in the UI. The task column, let's take a look at the task column. The task column itself is pretty simple. It uses a card component from Sassian UI. Where is this? Here. The card component from Sassian UI. The card header here is going to render the column data and the column ID. It also render 2 buttons. The first button here is for drag and drop. It's called drag handle. We will implement this later. And the second button here is for delete the column. The card content here is going to render the children. It's where the task items are placed. The task item component is similarly straightforward. It takes an item data and render it inside the card component. Back into task management component, you will see scroll area component here. I'm going to use it because it argues native scroll functionality for consistent and cross-browser styling. In our static app, when content overflows, the scroll bar only appears on hover, and it is styled to give a smooth, polished look. How should we structure our data to derive this UI? And the first approach, normally we will use array-based approach. Let's take a look at this data. So here's initial data 2 I made for you. So we can structure our data as an array of objects. Each object is the data of a column. So you see here we have ID, column ID, data, and children. Children here is an array as well, an array of objects, and each object is for the data of a task item. So it's very simple. We might render the app like this. So we map through the item in the array, and for each column, we are going to render a task column, and for each children of a task column, we are going to render a task item. There's a drawback with this structure. For example, when I drag a column and I know that the ID is, for example, in progress ID, and I want to access the data of the column. The normal way with this approach is that I will need to iterate over the array and find the object with ID in progress ID. But it takes linear time and we need to scan through all the item in the array. And if we read it frequently, it will not be efficient. So to address this problem, I'm going to store the data in this structure. We're using an object to store it. So the key here is the ID of the column. And the value here is still an object where we have data and the children. So now if I drag a column and it gives me an ID like in progress ID, if I want to access the data, I just use initial data and square brackets in progress ID. And now I got instant access to the object. And how we render it in the UI? So we need to iterate through the data. So what we need to do here is we are using an object keys and pass initial data. So it will convert all the key of the object and put it into an array like this. So we got column IDs. It's like to do, in progress, and done. And now we map through the columns IDs. And for each column ID, we are going to render a task column. Now the data we access, for example, for the column, we can access by using initial data and column ID. And similarly with the children, initial data, column ID, and children. Okay, with this approach, it solves the problem with um, finding the column data quickly, but it introduced a problem. We cannot keep track of the column order because the object we don't in the object we don't have order. Objects unordered. So an array has order. It's like we have to do ID, in progress ID, and done. And if we change the order, for example, I'm going to move to do ID to the last position here, and the order changes, it's fine. So this is why I'm going to store the ID in the state. And later, if we change the column order, this will have it update the UI. Of course, I will keep track of the data with the initial data of the object because it will change in the future. As you can see in this final app, the columns themselves are sortable, and the item within each column are sortable as well. And to make this happen, I will use dnd-kit Sortable Preset. Here is the structure we will implement. First, we will need to wrap the entire app inside DndContext. And since each task column needs to be sortable, I'm going to wrap them inside a sortable context from dnd-kit Sortable Preset. For reusability and to support drag overlay we covered earlier, I'm going to create a wrapper component called Sortable Task Column. It renders original task column, and you use Sortable here and passes necessary props for task column so that it can trigger drag and drop operation. So inside each sortable task column, and I can say inside task column, task item here are a sortable list as well. So I'm going to do the same thing. I will wrap task items inside a sortable context and create a wrapper component called sortable task item that render task item. Inside sortable task item, it will use useSortable and pass down uh, useSortable return props down to the task item. And within this setup, we end up with nested and cross-sortable list columns. You can drag around an item you can drag within or between columns. Let's start implementing sortable in the code. First, you go to task management component. I'm going to clean up the thing that I want you. I will wrap the entire app in dnd-context. Give it an ID. Let's call it dnd Kanban-context ID, for example. Task columns are sortable, so I'm going to wrap them inside the sortable context. Sortable context requires an item props, and I will use column ID, which is an array of column IDs. Now, task item here also needs to be wrapped inside a sortable context. And the item I will use data and the column ID and the children. After setting up the context, we need to consume them with useSortable hook. I will create a new component called sortable task column, which uses useSortable and renders task column. First, copy task column .txt file here, and then rename it to sortable task column. We need to rename it to sortable task column component. And we need to rename the interface as well. So how about sortable task column props? Because sortable task column acts as a wrapper for task column. So we'll keep almost all of the task column props and except style and ref. So I'm going to delete style and ref. In the return here, we need to render the task column and pass in the necessary props. So the first prop here is children. Then we have class name, column equal to column prop, column ID, and on click delete. Next, we need to import useSortable and use it here. So I'm going to import useSortable from dnd-kit sortable. I'm going to call it, and as we learned previously, it requires an object with ID. The ID here is we are going to use column ID for useSortable return an object, so I'm going to destructure it and get property that I need. So I'm going to extract listener attribute transform transition is dragging and set node ref. We need a style to make item move, so I'm going to create a style and with a type of CSS property from React, and then the first value here is transform. We use CSS utility from dnd-kit utility and transform to string method, and I'm going to string method, and we will pass in transform. We need to set up transition as well, and just use transition here. Okay, now we got style. We can pass in style as prop to task column. So we got style equal to style, and ref as well. Ref equal to set node ref. We also need to pass attribute equal to attribute listener equal to listener. Okay, you get an error here because we haven't defined the two property yet. So let's go to a file called Kanban-style. So here is a place where we define a type, and I will call it sortable props. Now, as you learned from dnd-kit sortable previously, we are going to use some utility to extract the listener and attribute type from useSortable. So I'm going to use type of useSortable. So it gives me a type of sortable, and I'm going to get the return type. So we got an object. Now I only want attribute and listener, so I'm going to fix from that type to attribute equal attribute and listener. Okay. Now let's go to task column. I'm going to extend the prop sortable prop. Okay, we got attribute and listener, but I want it to be optional. So I'm going to grab the type inside partial. Okay, now two property are optional. Now let's use attribute and listener. The button with the icon grip here is where we will trigger drag operation. So it is drag handle. So we need to pass the listener and attribute here. So I'm going to spread listener and attribute. Okay, let's go back to task management. And in place where we use task column here, I'm going to replace it with sortable task column. Let's check the browser again. Let's try to drag and drop or reorder column. So you see it kind of work, right? The column is moving. Let's do the same thing with item here. So I'm going to create a sortable task item, just as we did with sortable task column. So we are going to copy the file and rename it to sortable task item. We need to rename it to sortable task item. Rename prop to sortable task item prop. Okay, we need to render the task item. So we got task item. We remove ref style but in class name item. And we want to use sortable here. So we got import use sortable. Its ID equals to item.id and extract the value. We got listener attribute transform transition is dragging and set node ref. We need to pass attribute listener and ref as well. Set node ref. Now we need to define attribute and listener type for that component. So let's go to task item and I just import the sortable props that we just define and extend it. So I make sure it's optional. Props from that type. We got attribute and listener define. We want the entire task item becomes the drag handle. So basically we need to spread the attribute and listener prop here. Okay, let's check the app again. I try to drag to do, oh, it doesn't work because I forgot to add style to this. So we got style equal to set property and equal to transform cnet transition equal to transition, and I'm pass style to this. We need to go back to task management again, and we need to replace the task item with sortable task item. Let's check it again. Okay, item are sortable. The next thing I want to do is to give a column and item a little bit style when we dragging. So let's go to sortable task column. And in the class name, I'm going to give it a class name opacity 40, and the border amber 500 when is dragging is true. So we're using from useSortable, and just keep class name here. And we go to sortable task item. Do the same thing with is dragging, and let's give it class. I want it to have a opacity 40 and border amber 500 when is dragging, and we got class name is, and maybe the default class here is cursor pointer. Okay, let's check it again. Now I'm going to drag a column. So you see the opacity and the border and that item as well. I think cursor pointer is not good, so we are going to use cursor grab. Now here is the hand here, grabbing. We are encountering a couple of problems when dragging an item. It ends up behind other items. That's due to how CSS index works, and I cannot drag it, you know, um, beyond the edge of the list. The UI stutters and lag, right? So this is the final behavior I want. When I drag an item, there's a single overlay element on top of everything, and its movement isn't constrained, so we can move around. Column behavior is the same way we have a column overlay. To solve this, I will use drag overlay component provided by dnd-kit core. In the task management function component, Let's find the DND context, and at the very end of the DND context, I'm going to import and use drag overlay from dnd-kit core. The children or the content of drag overlay depends on the type of item being dragged. So if I'm drag an item, so the content here will be the task item. The overlay will be task item. If I drag a column, so the content of the drag overlay will be the task column component. So to know which type is being dragged, I'll listen for on drag start event and save the drag item inside a state. So let's go back to the code and I will create a state here. Let's call it active item, active ID, set active ID, and use state. The type here will be unique identifier. It can be string or number. Now at DndContext, I'm going to listen to on drag start event, and we will create a function called handle drag start, and we define a function here on drag start or handle drag start. We got an event, and it will be drag start event from the kit core. So what we can do here is when drag start, we will keep the ID of item we are dragging inside the active ID. So we got set active ID. We go to event dot active and ID. Now to keep the UI here tidy, I'm going to create a function that render drag overlay. So let's call it render overlay function. And let's define a function here for function render overlay, and just return drag overlay. And I can define a content here, the type of React node, and the default here is null. So we can render null content here. So now we will assign content to task column or task item depending on what item we are dragging. So let's define 2K here. We are drag a column and drag an item. So how do we know if we are dragging a column? It's very simple. We can check a condition. So if there's active ID and data.active ID, this is where we are dragging a column. Why is that? Because the data here, as you can see here, and the initial data. For example, if I drag a column and I got active ID is to ID, and I say data.to ID, and we got the value, this means this is column. Why? Because this is the data of a column. So this is a column. So we basically say content equal to Now I'm going to render a task column. Now we got a column ID equal to active ID, column equal to data.column active ID. Okay, and we need to render the task items inside a column as well. So let's give it scroll area and the class name is full page 2. Just keep the same here. Maybe I will copy everything inside this. Now instead of column ID, we got active ID. Okay, let's check it out. Okay, now I try to drag a column. You see it going to render a task column. Let's do the same thing with the task item overlay. The content will be like this, equal to the task item. And then we have item equal to something here and class name. And let's give it cursor wrapping. So now we need to find the active item data. How to find this? There's a way. We may, if we have active ID and it is an ID of an item, we may need to find the column ID. And from that column ID, we can look through the data of the children of the column data and find the item that has the ID match active ID. So first we need to find the column. And how to do that? Maybe we need to define util to find column ID. Let's call it function find column ID. And it will take an ID, the unique identifier. And we can do this way. We first check if the data ID has value or not. If they return an object, this means this is the column ID that we know. Otherwise, we will find the active column ID based on that ID. So we can look through the column ID list and find. And for each column ID, we find the data dot column ID and children. And we use some method. If the item inside children has item.id equal to the ID. So first we will try to qualify column ID here, active ID. So what we need to do here is return active column ID. So we comment this first and try to format the code. So this function here basically saying if we got an ID, if it is the column ID, we just return that ID. Otherwise, we need to look through all the column data and all the children and find item that has the ID provided, and then we return the column ID. Now we got an error here because active ID is still undefined. Maybe we need to make sure it won't happen here. So maybe we put the condition inside a nested one so that TypeScript realize that. So we got data. Okay, now we can find a column ID. So you can check if there's column ID. What we need to do is to find the active item data. So we are going to look through the children of a column, the active column here, and then we are going to find the item where the item.id equal to active ID. And then when we have active item, we are now simply to pass it to this content. Okay, let's check the app again. Okay, now we solve all the problem with drag overlay. We will move on to an important section, collision detection algorithms. If you are building complex drag and drop apps like this, you need it. A collision detection algorithm in this context essentially answers two questions for us. When dragging an item, where do we expect this item to be dropped? And how do we know or calculate the position of that drop location? For example, when a user wants to drag to do column and drop it into in progress column. So the expect drop target here is the column in progress, and the calculation could be based on the moment when the to-do column touches it in progress. Okay. However, in some cases, users expect different behaviors or calculations. For example, dragging the to-do column under the in progress column without requiring overlap between to do and in progress, and the user expects that to do match in progress, as you can see in the final application here. Okay. Another example, when dragging a task item, for example to do 2, from the to do column to the top position of the in progress column, it should matches the first item, here the in progress one, and we can insert to do at the top. Maybe you can check out the final app. And similarly, when we drop it into the very bottom, it will insert to do 1 at the end of the list. Okay. In other scenarios, using wrong collision detection algorithm can lead to a frustrating user experience. For example, when I drag to onto in progress 2, okay, so I expect that in progress 2 will be matched, but maybe using wrong algorithm, it will detect a match with the column here, the in progress column, causing to do one maybe to be insert at the top or the bottom at the list, so user feel frustrating about that. Therefore, we need to customize the collision detection algorithms. Here I'm in the page, the document page, collision detection algorithms. So we can take a look at some built-in algorithms that dnd-kit provided. For example, here we have a rectangle intersection. So it's the default behavior inside our app right now. So the algorithm works by ensuring there's no gap between any of the four sides of the rectangles. Any gap means a collision does not exist. So you can see in this figure here, the image, you see that here is a droppable item and here's a draggable item. Now suppose I'm dragging this item with ID 1 and you see here there's an intersection between the droppable and the draggable. So it will match this droppable with the ID A. And another one is closest center. So the closest center algorithm finds the droppable container whose center is closest to the center of the bounding rectangle of the active draggable item. So you see here is that two droppable A and droppable B. And now here's a draggable item with the ID 1. So we have two lines here, the center of draggable to droppable A and the center of the draggable one to droppable B. So you see the green line and the red line. The green line here is shorter than the red line. So because it is closest center, so we expect and the algorithm gives first this droppable A. It will match droppable A. Closest corner is pretty similar to that closest center. We don't need the intersection between draggable and droppable. So we can read more about that. Pointer within. The pointer within collision detection algorithm only registers collision when the pointer is contained within the bounding rectangle of the order of other droppable containers. So this collision detection algorithm is well suited for high precision drag and drop interfaces. So let's take a look at this figure here. Maybe you see the hand here. The hand here is considered a pointer. So if we are in situation like this, so this item will match this column, this droppable B here, because the pointer is stay on top of this droppable. Okay, we can build custom collision detection algorithm. That's what we need in this app. So there are two approaches. We can build a custom collision detection here in the list. So you can read more about this here. But in our application, we can use the first approach where we compose existing algorithms. So I'm going to compose rectangle, close its center, and pointer within. So let's see how we can do it. To add custom collision detection algorithm, we are going to use a property, a prop of dnd-context. It's called collision detection. So let's take a look at the type of collision detection prop. So it has a type of collision detection, and in fact it is the alias for a function. The function here is it takes one argument. It's an object, and it returns an array of collision. And what is collision? Collision here is in an object we got an ID of unique identifier and the optional data attribute. So we will need to define a function. Let's go back to task management, and we can call it custom collision detection algorithm. And let's define a function here. So we can define a function, or we can define a variable, an arrow function, because we got a type collision detection. So I'm going to copy this variable here and give it a type of collision detection from dnd-kit call, and it satisfies a function, and it will have argument. The type here is an object, and let's see how it works. Now, the function it expects that we are going to return an array of collision. So let's see what happens if we return an empty array. Okay, let's check the app. Now I'm trying to drag the to-do column. You will see that it matched nothing, like no item. Just because our algorithm basically say, okay, I'm doing a lot of many calculations, and finally I see that there's no matches. That's why I'm going to return an empty array, because it is an empty array, so it match nothing. So let's try to give it a fixed ID, return fixed IDs, let's say to do item 3. So it expects an object ID to do item 3. Now I'm going to drag to do item, and you will see that it always match the to do 3. That's why the list insert to do at this position. It always match to do 3. And that's it. This is how the custom algorithm works. We should return an array, an object where the object contain an ID. So we can give return an array with one or more item. So let's say I'm going to return another one here with to do item 3 and to do item 2. So you notice a behavior. It always take the first one. Always take the first one. Let's check the app again. And you see that it always match the item to do 3. You can swap it to verify. There are two cases we consider here. We At some point of time we drag a column. So I'm say dragging a column and dragging an item, a task item or a task column or a task item. And finally we return something. So we will handle where the case when we drag a column first. With columns, we allow user to sort the column by just drag and, for example, I'm drag in progress over the done column here, so it will swap, and we just want to say our custom collision will return the done ID here, or we allow user to drag in progress and match the column done without touching the done column. This is a hint where we want to use the algorithm closest center. Let's take a look at the finger here, the closest center. Let's say I drag column in progress and I click and drag it to this position. Now the closest center algorithm calculates the center of in progress with done and in progress here. So you see the green line is shorter than the um, pink line here. So the green line will take effect and it will match the done column. Let's go back to the code and implement. A user to know when we're dragging a column, we can check the active ID. So remember, when drag start, we already store the active ID in the state active ID. So now if there's active ID and we got data active ID, this means we are dragging a column. Let's use closest center. I'm going to define a variable here called closest center draggable list, and I'm going to import closest center from dnd-kit call, and the function is exactly the same thing. Satisfy the type is the function and return collision. So the argument here is match, and we can pass argument directly to this function. And we just return this. Now we can try to log it to see the return. Now let's drag to do column. You see that it doesn't work correctly sometimes. Let's try to drag in progress. And why is that? Let's take a look at the return object return array from the closest center algorithm. You see that the 10 item return. So why is that? You see that we have to do in progress done. So it's sortable item, right? Because sortable item is it both draggable and droppable item. So we got 1, 2, 3, and the items inside here, the card item or the task item, also droppable. So we got to do 4. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it returned 10 items. And because there's 10 items, the closest center doesn't work correctly because it's, it may match. Let's say I try to drag this one, and the first item here, it return, it's matched in progress item 3 because the center from this point to this point is closest. So we need to somehow ask our algorithms, like, we only want you to calculate to do in progress and droppable and done, and please ignore the items, the droppable item, the task items here. So let's see how can we do this. If you take a look at closest center, we can pass an object to configure behavior. So one of the things you see here is droppable containers. It will contain 10 container as you see, but I think we can pass only column IDs, column container there. We can do this by first spread argument, and we can change droppable container. So we just want 3 columns. So here how can I do? I'm going to filter this by using argument, droppable container, and filter. I'm going to filter all the droppable ID in data. Or in other words, you can say data and square bracket droppable ID. Basically, we can check if this ID of a droppable container here is in data or not. Remember, our data is an object, so if we got data and the ID, we got a column data, so that is a column. Okay, let's see, check again. Now I'm going to drag to do column. Okay, you see this close it is in progress, so it match in progress, and sortable automatically swap the position for it. And you can see in the log, it always contains 3 droppable container. This is to do in progress and done. So which one is the first item in the array if we will match? For example, I try to drag this and I want it to match done. Okay, you see that the column done is returned, the first item in the array. Okay. Next, we are going to handle drag an item. So I will try to use pointer within and rect intersection and log that so you can see what's going on with this, and then we'll try to uh, decide what to do next. So I'm going to say cons pointer within list and import pointer within collision detection algorithm function from dnd-kit call and pass in argument. And the next thing here is rect intersection equal to rect intersection Okay. I will drag to do item 1. So you can see here, like my pointer, you see my pointer, it stay on top of to do, right? Stay on top of to do. So if we are using pointer within, it will return one item with the ID of the column to do ID. And you also take a look at the rack intersection. You see that it intersects with to do item 1, and it also intersects with the column to do, and you see that it intersects with in progress column and in progress item 1. So maybe the list will return 4 items. Let's take a look at this. The pointer within here is the to do column, and the intersections list will be to do ID, to do item 1, in progress, and in progress item 1. Can verify that again. Now sometimes the pointer work like this. We have a both pointer and rack intersection. Both matches to do the column to do, right? And sometimes we have only rack intersection. You notice my pointer is outside the to do column, and there's an intersection between to do and to do item 1 and the column to do. So you see that the pointer within list will be empty, and rack intersection will be the column to do ID. So in an app like this, we will prefer using pointer within first because it is high precision, and when the pointer within is not available, we use rack intersection in like this case. Otherwise, the pointer will be better, right? Let's say I'm drag to do one and I want to drag into in progress. So you see that this pointer match in progress and in progress item 1, and also the rack intersection match meant multiple rowables. But as user, I expect that my pointer match in progress 1. So we can do this in the code by saying we can define a variable called intersection, and if pointer within list is not empty by checking the length, we will return pointer within list. Otherwise, we use rack intersection list. And because the algorithm works by select the first item in the intersection return, we can try to get the first one. So let's define a variable called over ID, and we can manually like intersection, do intersection and get the first item and then get the ID. But maybe you can use an utility called get first collision from the dnd-kit call, and we pass in an intersection here. And the second argument is what property from the first argument we want. So I want an ID. So now an ID over ID will be type unique identifier or null. So in case the pointer within and rect intersection will be null. For example, when I drag this item outside like this, there's no pointer within and there's no rect intersection. So this over ID will be null. So let's check the over ID again by log into the console. Maybe we'll try to drag an item in progress 2. So there's a rect intersection, there's pointer within, but we prefer pointer within. So uh, you see my pointer here, and it will match in progress 1. In this case, it match the column in progress ID and done and to do 1, to do 2, to 3, and the column to do. And in this case, it will still match to do ID because there's a rect intersection. There's no pointer, but there's no match in pointer, but the intersection will have value, so it still give it to do ID. And then we put it outside and we got null. Now we can return it so that it work like this. So maybe we check if there's over ID, we return this part, otherwise we return nothing. Let's check again. Okay, it's mapped to do 2 and 3 and 4 and the column to do. And so on. Inside the list it works fine. You might notice a problem. For example, if I drag this to do 2 here and it matched to do 1, 5, right? What if it matched to do 2 to do column? You see that it will go back to this original position to do 2, right? You see to do 2 here, and when it matched to do column, it will go back to the original position. Ideally, it's not we want. Maybe we want it to match the to do column 1. And you can check out the final application here. When I drag to do 2 and it match the to do column, it still match the first one. And even when we drag it to in progress column, it should match the first item in the list, as well as the to do in the button. So when it match a column, and which it should match some item that user expect, it should not go back to original position. So what we are going to do here is we are still using closest center, and you can check out the figure here. Let's say we drag to do okay over to do 1, and it match to do 1 because my pointer stay on top of to do. And now we go to the to do column. My pointer match to do, and because it match to do with the list here, it will return nothing, right? So the sortable list only work inside the context of the sortable list, and because of that, it go back to do 2. But we can custom the collision detection algorithm by saying, okay, when you drag this item and it match a column, we should use closest center to we take the droppable. So let's say if I drag this item there, and you see that if you are using closest center for the four to-do items inside the list right here, you see that the to-do one will match and it should return to-do one first. And remember, to make this algorithm work correctly, we should apply to the column, to all the items inside a column where the item is matching. So we drag to do 2 and it match the column to do ID to do, and we apply to the algorithm or ask algorithm to check for droppable here all the item inside the column only. Let's go back to the code and implement this. Okay, when we got over ID, it worked fine with the item. If the over ID is item, but if it is column, we need to handle this, and we set earlier, so we can say if data.over ID, so it return data means this is a column. It matches a column, and we can get all the children, all the items of the current column. So we can say column item equal to data.over ID and children. And if the column has items or children, we want to do this if column item dot length is greater than 0. We can calculate new droppable container. Filter from droppable container where the droppable. So we got droppable ID. It's different, or it's not equal to over ID. So over ID in this case is a column, and we want to filter out the current column, and we want to get only the droppable of current column. So we can say column item dot file item and item dot ID is equal to droppable ID. So this condition here is basically make sure that we exclude the current column, current matching column, and we only get the items, the item inside this column. And now we can use closest center again to implement. I'm using closest center. And as usual, I'm going to spread argument and adjust droppable container by using new droppable container. Let me try to lock the new droppable container. And let's give over ID equal to the first item and ID. Okay, let's check it out. Now I'm going to drag to do item 2 and it matched to do column. So you will see that it matched over ID because you will see that it matched to do ID because we got over ID here. And now we got new droppable containers. We calculate and it return 4 items inside it to do ID. And we apply closest center algorithm to find the closest one. And the first item returned here is the to do item 1. And this is why we matched to do item 1. Okay. Similarly, it will match to do 3 here because to do 3 is sorry, it will match to do 4 here because to do 4 is the closest one. Here is another problem. If you drag to item 2 and it match nothing, so to do 2 will be it go back to original position. So first it matched to do 1, okay, it still match to do 1 because we are matching the to do column. And the moment we are outside or we match nothing outside the column, it go back to original position. But user may expect that it will still match to do 1 right there. So you can see in the final application. So I'm drag to do 2 and it matched to do 1 and still match when we drag to do column. And when the moment we are outside this, it still match to do 2. Okay, so how do we handle this behavior? What we can do is we can keep check the last over ID, and then when there's no match, we can, if we see that it match, the last match is some ID, we can return that instead of return nothing here. So maybe we can try to keep check it inside a ref. So maybe we can call it last over ID. Okay, we give it unique identifier and null. So when we got over ID, we can keep check it there. Let's say last over ID the current and over ID. So this case where we match nothing. So instead of return an empty array, we can say its last over ID has value. If it has value, we can return the last value. otherwise we return empty. Right. Okay, when I drag to do item 2, it first maps to do 1, and when it's matched to do column, it match the to do 1, still match to do 1 because of closest center. So in this case, we store to do item 1 in last over ID, and when we move outside over ID none, but because we just keep track over ID, the last over ID is to do item 1, so the to do 2 here still will be placed in the first position of the list as we expect. Okay, that's it for custom collision detection algorithms. In the next session, we are going to actually update the order of column or item when drag operation end. As you can see right now, when we drag a column, and for example, it's matched to do, and the moment I release the mouse, indicating that the drag operation end, it go back to the original position. That's because of we are using Sortable Preset, and the moment we drag this, the UI reflects the changes. It create automatically create that animation for us. But to actually update the order, we need to update the state. So to update the state, we need to listen to on drag end event. So let's go back to the code, and I'm going to define a function here called on drag end, and let's call it handle drag end, and I will define a function handle drag end, and let's give it event of drag end event. I'm going to pull out active ID equals to event active ID and over ID. We need to handle two cases, and the first case is drag a column n, and the second case is drag an item n. So first I will try to lock the active ID for drag and active ID, and let's go back to the UI and try to drag a column. So I'm going to drag the column to do and drop it over done column. Drag and event give us information. The to-do ID is the active ID, and over ID is done ID. Similarly, with in progress, active will be to-do ID, and over will be in progress ID, the in progress column. Now, as we learned from sortable list previously, we need to update the state to reflect that change. So let's go back to the code and implement this. To make sure that we are dragging a column, we can check if there's active ID first and over ID. And if data active ID has value, this means we are dragging a column. So What we need to do is update the column IDs. Remember the state here is column ID. Column ID is an array of column ID derived from the data. And because the data is rendering based on the column ID, so if normally we will have to do in progress and done, and now if we change the order, let's say to do move to done, with update this array, and the UI will change accordingly. So we will update the state set column ID, and I'm going to use the updater function, and let's call it column ID. We need to find the index of active column and the index of active column and over column. So let's define active column ID equal to column ID dot find index, or in this case it's just an array of strings, so I can use index of instead, and active ID. Similarly, we have over column ID index. So define here is index column ID index of and over ID. Now we can create a new column ID by saying new column ID, and we are using array move as we learned from previously. This is the function that helps us change the order of a sortable list in this case, and it expects column ID, and we are going to move active column index to over column index. So let's pass active and over. Now we got a new column ID. The last thing we need to do is to return that. And remember, when drag operation and we should remove active ID state, because currently we are not dragging any item, and we should return because we will not want to execute the code below. Let's try to check the app again. Now I'm going to drag to do and put it into the position of done column, and yet the UI is updated correctly. The next case we're going to cover is where we are drag an item and end this operation in the context of column. So as you can see here, I'm going to drag an item to do one within in this list of task item here, and it is inside the to-do column. So we'll cover this case. We're not going to cover the case where we drag to do and move to another column and we end the operation. We will have another listener for that purpose, but for now we only need to care about dragging an item inside a column, and that operation ends. So first, what we need to do is to find active column ID and then find column ID by active ID. I will try to write the code first and I will explain why we need to do that. So we got active column ID. If we cannot find active column ID, we should do nothing. So let's set active ID to none and return. And if there's no over ID, we'll do the same thing. Set active ID equal to none and return. So while we're not dealing with the active ID and it doesn't have active column ID. So if I drag a column, an item, let's say to do 2, and it it must belong to a column, right? I mean, it's very special, okay, when we drag this item and it doesn't belong to a column. Maybe it's not belong to our application, for example. So we will terminate the operation and so on. The next thing is if there's no over ID, we should terminate and do nothing with drag and event as well. Why? Because we are dragging this item and it's not over. It doesn't match any item. And this is wrong, right? And the next thing we need to do is we need to make sure that both active item and over item should be in the same column. And that's why it's safe for to update the item. So let's go back to the code and check this. And we need to find the over column ID by using file column ID and got over ID. So here's the real condition. We must check if there's over column ID and active column ID and over column ID is equal to active column ID. So if we are dragging to do and it's over to do 3, for example, active ID is to do items 2 and the active column is to do ID and the over ID is to do item 3 and the active over column ID is still to do ID. It means it is in the same column. Now we need to find active index and over index. And we need to check the data of active column ID and children. And we find index where the item with ID is equal to active ID. Over index, the same thing. Item.id is equal to over ID. We want to update the list, the item in the list. If active ID, active index is not equal to over index. Why? Let's check this. So I'm going to drag an item to do item 1, and the active item here is to do item 1, and in this case it's still over itself, like it's still over to do item 1. So in this case we will do nothing because as therefore the item will go back to its original position. But to do is over to do item 2, then the active item and over item is different. So now we can update this. So remember our data is organized like this. This is a column to do And let's say I drag to do item 1 and move it to the position of to do item 4. So theory, we will need to update this, remove this item and put it there, and the items move up, right? So this is what we know. We need to update the children of column with a new orders. What we can do is we can update the data and using updater function. I'm going to create a variable called new data and set it to spread the current data, and then we need to update the column, and we can use over column ID in this case, and copy everything from data.over column ID and then actually modify the children. It's something here, and we return new data. So how do we calculate children? It's very simple. We can create a variable called new over column children, and we're using array move, and with data over column ID and children, and we move active index to the position of over index, and we are now need to assign it to children. And finally, just try to set active ID equal to null whenever the operation ends. Let's check again. Now I'm going to drag to do item 1 over to do 3, and yes, it is updated. And now I try to drag it over there. You notice it doesn't work because our condition is active item and over item should be in the same column. The next important thing we need to cover in this app is we need to update state when we drag an item cross container like this. Here's our final application. You will see that we can move to the item to another column and put it there. So how can we do this? So our current application is like we handle everything in drag and in the context of a column, and it works fine. But when we move to different column, it doesn't work. So we need to listen to an event called on drag over, and we will do some update. Let's go to the code and go to dnd-context. I'm going to define on drag over, and let's call it handle drag over. Let's define a function called handle drag over, and the event here with a type drag over event. Let's pull out active ID and over ID. Now we need to check the condition if there's no over ID or the data that active ID, we will do nothing. Why is that? Because the first condition here is if we are dragging an item and it's over nothing, this means we will not handle this case. And the second thing here is data.active ID. So in this case, it's like we are dragging a column. So dragging a column is not a problem with our app right now. The only thing we need to care is we're dragging an item and it is over a container, a different column. So the next thing we need to do is we need to make sure that the active item column, for example, to do column, and when drag it over the in progress one, for example, the column is in progress. So we need to make sure that active column is not equal to the over column. That's why we need to find active column and over column. Let's call it active column ID equal to find column ID and get pass active ID and over column ID find column ID with the over ID. So we need to check if there's active column ID and over column ID and active column ID is not equal to over column ID. And that's where the logic goes. So our goal here is to find the active index of the active item. So let's say I'm going to drag to do 2 and the active index is 1, and later we need to remove this from the current list. And then we will move to new container, new column. We need to find the index of the item we will want to drop onto. For example, I want it to stay on top of the list. So maybe the index in this column in progress children will be 0. And let's go to the code and check it. Maybe we need to pull out the children of active column and over column. So let's call it active item is equal to data.active column ID and children. And over items equal to data dot over column ID and children. We need to find the active index of active item and over index of over item. Active index equal to active item, and you can find index where item ID is equal to active ID. And over index equal to over item. But find index with the item ID is equal to over ID. Now with this active index and over index, we can update the state like from the index 0 up to do, we delete this to do, and if we find the index is to in progress 2, maybe we'll insert to do in this position of in progress 2 and push in progress 2 and in progress 3 down. But we need to handle an edge case. For example, if I drag to do and I move it to in progress 3. So in this case, you see that my item is stay on top of in progress 3 and it match in progress 3. So as user, I will try to insert to do in the position of in progress 3 and push in progress 3 down. Okay, maybe we go to final application and see this. I move to do 1 and move it over to in progress 3. So to do get inserted into in progress 3 position and in progress 3 go down. But what if I drag it and it's still match in progress 3, but it's from this position? So maybe my item is below in progress 3 and you know that it should, the question is we should insert to do in the place of in progress 3 or below. Like in this case, we insert it below. It match in progress 3 because of closest center. And because it's below in progress 3, so we put it there. But what if it's over in progress 3? So it's time where we insert to do in the position of in progress 3. So basically we need to check if the item we are dragging is on top of over item or below. So it's over in progress 3 or below in progress 3. If it's over, we insert in the position of in progress 3. If it's below, we need to add or insert into the index by +1 so that it appear behind in progress 3. So let's define a variable called new index and the type is number. We need to check if over id in data. And there's another case here. So the first case here is we are dragging an item and over id in data. This means we drag this item over a column and it match a column. But you know that if the column has item inside, it will never match the column because our custom collision detection algorithms say that we will use when it match a column using pointer or red intersection, we'll select the closest center item in the list. But when we move it to the empty column like this, there's no items inside. So actually in this case, it will match the column. And because it's match a column, we need to basically set the new index is to maybe 0 or 1 here. So let's go back to the code and define the new index is equal to over item, the length +1. So let's comment here it matches empty column. Match an item in another column. There's a method to calculate position of the dragging item is below another item or not. So let me write down first and I will explain that. So let's call it is below over item. and we can check if that's over. And active.grab event.active, which say event.over. Drag.current. So maybe let me try to destructure here. Let's say active to make it shorter and over. So we can say over and active directly. Now we can calculate active dot rag dot current dot translated, and the top is greater than over dot rag top plus over dot rag dot height to make sure that translated define. So we can define a modifier. It basically, if it's below over item, we will add one index, otherwise we'll add nothing, we add zero index. So our new index will be equal to over index. We should check the over index if it's greater than zero or not to make sure that we are dragging over an item. So we say over index plus modifier. Otherwise, we just say over item dot length plus 1. Okay, let's take a look at this way to calculate if an item is below another item when dragging. So we got active item and we got over item. So active rag current the translated top give us information about the top of the current active item. So maybe I will try to draw a thing right there. Let's say here is the viewport. And we have active item. And maybe we have another over another item here. So let's say I'm going to drag this item and I move it there. Give it another background. So once the top up from this place to this place, the item translated, and the top of the item will be calculated this way. Okay, and the over item top and high. So here's the over item. Top here from here's the top and here's the high of current item. So you will see that this line plus this line is shorter than this line. So this means this item is below this item. So basically, that's the function. That's how we calculate this. And because the new index will be in the position of over item, or it is below, we need to add 1 to this so that it appears below. And that's why we need to do this. We just say over index plus modifier. Okay, now this is the time we need to update the state. We can create a new data and copy everything from data state. We need to remove the item from the active column. So if I drag to do one, I need to remove it from the list of the to-do column. So we can say active column ID and copy everything from data active column ID. And we need to modify the children by saying active item filter. The item, we need to filter out the item match active ID. Okay. And for the over column ID, we need to do the same thing by copy everything from data to over column ID. Children will be new one. So maybe we need to define the new children here. Let's say we're going to spread new over item that I'm going to calculate there. Okay, here how we do it. So pretend that to do one match in progress 2, and we know that the new index will be 1, 0, 1. What we need to do here is I'm going to cut or copy this part, insert the active item at the position. So I'm going to insert to do at that position of index 1. And I'm going to copy this part and put down. So let's go to the code and say I'm going to copy everything from the beginning of the array to the new index position. So we got over item dot slide from the beginning to new index. And I'm going to insert that active item. So I'm going to insert to do to that position by saying active item, active index. And I'm going to copy everything from the rest, from the index to the rest. So we got over item and slide from new index to the rest. Basically, we need to insert the new item at the position of new index. And this is how we do it. And now we got new data. The last thing we need to do is we set data equal to new data. Let's check the code again. Let's try to drag to do, and it below in progress. Yeah, it insert the to do one below in progress. And how about over in progress? Yet it insert to do one in place of in progress and put this item down. How about we move this item to an empty column like this? So it will insert a new this item to that empty array. The last thing I want to cover here is when we cancel a drag operation. So if I drag to do one and I move it to in progress, so to do get inserted to in progress, because our state is updated. And I move done, for example, and so on. Now, if I cancel the operation because I just realized that I don't want to drop it there. Now I want to go back. dnd-kit support cancel the operation by, let's say, press ESC escape in the keyboard, and I expect that my item will go to the original position. But it cannot, because our state is updated and we cannot go back to that original position. Let's try again, and I want to cancel this. Press ESC, it cannot go back. So uh, sometimes you want to support this. So let's define a state. Let's call it clone data. And we are going to use state and maybe shallow copy the data. So what we need to do is, when drag start event happen, we may want to store the current state in clone data. So we'll set clone data inside and pass the data there. And dnd-kit gave us an event called on drag and on drag cancel, and we can create a function to deal with that. Cancel. And what we need to do is, we can update the data with the clone data. And remember, the column should reflect that change. So we also need to set column ID to the object of key dot clone data. So when drag start, we store clone data, and when drag cancel, we just set the state to the clone data. And let's check again. Now let's drag to 1, 2 in progress, and then I cancel this operation by pressing escape. Now the data get restored and this item go back to the original position. It's what the user expects. Okay, that's it for our application.